It's a little bit late, pero this is your fluid statics problem sets. Give you a few extra problem sets you can work on. Most of them I already answered. The Today you'll be seeing step by step. Those highlighted in red, boxed in red, those are the items that you can should be answering. I mentioned at least 4 or 5 items, but you get seven. Pero yung first four items, they're relatively easy. They're like conversion units. I want you to practice really yung unit analysis and how to actually convert them and analyze. Writing down yung problem to be exact. You're writing down your equation. Okay. So again, let's go over with your problem sets reading. So again, you highlighted in red are the ones who have their answers. So in this case, for the first page, it's 1, 2, 3, 4, 5. They have the final answer data. That is hence why I selected that red. This should be relatively easy to answer. Yeah. Hopefully you guys were able to talk to each other. So this is the one for manometry so that you get some practice. So this one already provided a sample, your more updated sample problems, more sample problems. So you should be able to have an idea of how to solve this there. I've already showed you in the previous recording on how to do that. Also going to provide you several other examples, just like so. What if it's in an angle? It's going to be, hope you did try this because this is a fun way of solving or problem solving. Commenting. And then for hydrostatic equations, it provide much buoyancy because it's relatively easy. But I provided a sample amount on your book, so that this should be good. Here for hydrostatic, this one is the one I gave you a previous example of is in SI. So this one is in ignition. So just be careful with that. Remember, all of the time, the conversion constant is being used for English so that you can cancel out your power acid or cancel power acid, power force, or power force. Just be careful. I've encountered some relative difficulty now in 373 and 375 because I'm having a disagreement with the things the authors of how he solved it. So because Tadewa should do the definitions the distance from the centroid and how he used your distance there, and that affected your answer and the dimension he used for the fixed area as well. Later on, we'll show you how it's done. Okay, let's go back to the previous ones. Just give me a double check there. Still recording. Again, let's start with this one. So we have you 3-7. This is a piston. Just suppose there's a building. So the piston here is a vertical. The piston of a vertical piston cylinder device containing gas has a 40 kilogram mass. So I think that the problem is mentioning this one is 40 kilogram. And a cross-sectional area of 0.0112, so 0.012 meters squared. So the local atmospheric pressure is 95 kilopascal and the gravitational acceleration is 9.81 meters per second. So in this particular case, the atmospheric pressure is given and the gravitational acceleration. So let's just forego 9.8066 meters per second squared that. So we're being asked A to determine the pressure inside the cylinder, and I'm gonna ignore question. It's good for your discussion. The answer is probably not gonna be doubling. Okay. So how do we go about this again? So we are required to identify your pressure inside the cylinder, and for us to know that, what do we currently have back? So based on the given, we're given a 95 kilopascal atmospheric pressure. We're given a mass of piston, which is about 40 kilograms. And we're given the common area data, which is equals to 0.012 meters per second squared. Meter squared. Then we have acceleration to gravity at 9.81 meters per second squared. The solution here, recall that pressure is equals to force over area, right? We're gonna draw a bit of FPD. There's a mass ng piston here, and the force ng cylinder being exerted here in the gas, and it buses or it creates a upward force dito. But the one resisting yung force upward na yun, or yung force ng cylinder, is yung weight ng piston and the atmospheric pressure. The force being exerted by the atmospheric pressure, basically. So when you look at it, may dalawa tayong downward force dito. And if we're gonna write the equation na yun, it's gotta look like this. Okay. So just for short analysis, then, if you're not really sure, we want to make sure that draw yung diagram. We're talking about, we're to determine yung pressure ng cylinder. You recall that the pressure ng cylinder is force over area. Hence, the formula that we need here is the product of pressure and the cross-sectional area. However, you're given atmospheric pressure, you're given mass. So what are we talking about dito? It is indicative that, you must take into consideration that the force generated, or the force generated by the mass of the piston and the atmospheric pressure, hence the FPD. So we have we're trying to find the pressure here, which exerts a certain force. Okay. This basically pressure that's by air, but at the same time, there's a weight here by the mass of the piston, 40 kilograms. So just multiply that by 9.81. And of course, open is a system, which is 9 point. Say may piston cylinder, meron tayong air intake. And it just so happen, yung atmospheric pressure at the air intake is 95 kilopascal. So, at that pressure, there's a certain force then. Okay? By applying the same formula. Okay, in this case, we just simply substitute lang naman yung alam natin dito. So, pressure ng cylinder times area minus atmospheric pressure times area as component of hydrogen. And then minus yung weight, which is the weight ng piston. So, we isolate the pressure ng cylinder and we have this particular equation. We divide both sides by area, magka-cancel out area dito, plus WA. Substitute yung values. Loading cancellation. So that will be 95 kilonewton per meter squared. That's 40 times 9.51 divided by 0.4. Yeah, so 40 times 9.81 divided by 0.012 meters squared. And then, of course, it's kilonewtons, so convert to kilonewtons, and then all units will cancel out. So it's kilogram meter second squared is Newton. Converted that to newtons, kilonewtons, factor that out, so making kilonewton per meter squared. So the pressure here ng cylinder is at 127.7 kPa. So that's one of the basic ones. So let's go back. All right, let's try naman 3.8, 3-8, 3-9, and 3-10 at the same time. So as you can see here, there's a little bit of conversion dito. Again, let's just practice a bit lang of conversion, okay? So here we are, 3.8, 3-9, and 3-10. Okay, so for 3-8, a vacuum gauge connected to a chamber rates 36 kilopascals at a location where the atmospheric pressure is 92 kilopascals. Determine the absolute pressure in the chamber. So, like I've said previously on our face-to-face lecture in my pre-recorded lessons, I mentioned here vacuum gauge. So you know very well that when you write this in an equation, it's gonna be negative 36. And given your atmospheric pressure natin, so this is 92 kilopascal, and we're just being asked to find your absolute pressure sa chamber. See how I wrote it. P vacuum 36 kPa. You could write the G here to indicate that, okay, this is gauge. When you write this equation, it's gonna be negative. The solution dito, remember that PF is equals to P atmospheric plus gauge pressure. This gauge pressure is just negative. Here we go, just like so. And then you will have 56 kPa, or you can also write it PABS equals to 56 kPa, or write it as pressure equals to 56 kilopascal absolute EBS. Either way, it's acceptable as long as you label them properly. Okay. No need for cancellation of units because the NE unit number is kilopascal. 3-9, the pressure at the exit of an air compressor is 150 psi. It's kind of like a trick question. This is what is the pressure in kilopascals? This is something I quizzed second year, and quite frankly, nalito ko sila. It's funny because they have thermodynamics, so I don't know what's the problem. So this is pretty much straightforward conversion lang naman. Even though sinabi na absolute pressure lang naman, it's just being asked, what is the pressure in kilopascals? All you have to do lang naman is to know yung constant natin. We know that for standard atmospheric condition, that's 14,696 pounds per inch square. So cancel that, divided by 1.25. So you have cancel yet. And you will have yield of the answer of 1,034.20 dpa, or 1,034.21 kilopascal. Speed what it? And then here we go with 3-10, another conversion sort of problem solving. In this case, the pressure in the water line is 1,500 kilopascals. We're being asked what is the line pressure in A, pound force per feet square, and then B, pound force in inch square. It's pretty much straightforward now. It's literal conversion problem now. So I do hope you still know your conversion. So in this case, we have 1,500 kilopascals. I know that yung atmospheric conditions natin as 101.325 kilopascal. That's 14.696. And then I just converted yung inch na yan to feet squared. And we will get 31,328 squared. And then the following naman, converted to pounds inch squared. So essentially the same process minus the conversion of inch squared to feet squared. So we have 217.56 pounds per square BSI. Yeah, that's pretty much the basic thing about conversion. Again, it's just a practice run lang naman. And hopefully you have ready message of cancellation of units. Okay, so I want you to keep on doing that and practicing that, because that will help you, at least assist you in terms of problem solving, not only here in this subject, but also in other problem engineering problem solving mathematics equations. Okay? And plus, this is a good practice then. And since you guys are going to be taking the board exam soon, this is a good practice when you're setting up your equations to scratch it. So even if it's in a scratch paper, you can organize your solutions and answers properly. Okay, and I added a few more. So there's 3-18. I call this the woman walking with snow problem, and then we have water reservoir problem dito, and then we have the barometric reading and the mercury barometer here. So we have 4 more problems of each one. So this is up. Just go back. There's no link. Anyway, this is 3-18. So here we go. All right, so consider a 55 kilogram woman who has a total footprint area of 400 centimeters. She wishes to walk on the snow, but the snow cannot withstand pressures greater than 0.5 kilopascal. Determine the minimum size of the snowshoes needed, so imprint area per shoe, and then to enable her to walk on the snow without sinking. I really want you to read the problem carefully, because although they provided a lot of figures dito, you gotta know which one do you actually need to use, right? So let's go with the problem. So we need to know yung area na gagamitin yung snowshoes. If you know yung sa mga movies for countries that have heavy snowfall and they require shoe attachments. They look like tennis rackets, to be honest with you. I haven't worn one. You know. So anyway, you're given the mass ng woman at 55 kilograms. 55 kilograms. So I don't want people asking me, sir, is it mass or is it weight po ba? Remember, when it's kilograms, we understand it as mass, unless otherwise specified. Okay? When bihira natin gamitin yung kilogram first, of course. So we have also a maximum pressure of 0.5 kilopascals. And the woman has a total imprint of 400 centimeters squared. Okay, that's her default footprint. But we're being asked, ano yung area ng snowshoe kailangan? And if you recall, pressure is equals to the quotient of force and area. So that's P equals to F over A, where area, manipulating yung equation, equals to F over P. We know that F here is going to be referring yung weight na woman, and weight is mass times acceleration due to gravity. Okay? And we can equate the following as mass times G over P mass. So we're given yung 0.5, we're given yung mass. All we have to do na lang is equate yung equation. So 55 kilograms, since hindi tayo binigyan ng acceleration due to gravity, we would assume yung standard na 9.8066 meters per second squared divided by yung imprint niya, which is 0.5 kilonewton per meter squared. I just converted this to Newton so that kilogram meter squared mag-cancel out. Yung Newton nito. Yep. And we're gonna be left with the unit meter squared. So that's lang yan. And we're gonna have an area of 1.079 meters squared or 1.08 meters squared. And if you ask me, that's all. It's a figure. So it's too much actually for one foot for the total area. Minimum size of the snowshoes needed. So it only means that's the minimum area needed so that she can walk on snow without sinking. However, that's gotta be physically impossible. So some level of snow sinking should be acceptable. Yeah. Okay. So how about this one, naman? So here we have a water reservoir. Water from a reservoir is raised in a vertical tube, internal diameter 30 centimeters, and under the influence of the pulling force of a piston. So determine the force needed to raise the water to a height of h 1.5 meters above the sea surface. Oh, so okay. So we're being asked to determine your force. For us to know that, we need to know several things. Okay? We're given height. Okay, that's good. And we're given yung dimensions na to. So technically, we can get yung pressure. Yeah. So we're being asked to find yung force at a height of 1.5. So, yeah. So, what are the assumptions na pwede natin dito? Since this is water, we can assume that it's not given here, but we can assume yung density ng water at 1,000 kg per meter cube and yung acceleration due to gravity at 9.806 per second squared. And to solve the equation, recall that pressure equals to F over A, and determine force is simply the product of pressure and area. And we also know that pressure is also rho times G times H. So equating them all together, we have this. So that will be 1,000 kg per meter cube times 9.8066 meters per second squared times height at 1.5 meters, and then area at pi r squared. So that will be pi 30 divided by 2 squared. So that's 0.50. And you will have cancellation of units, and you will have kilogram meter per second Newton. That's good. So all I have to do is newtons dito. That will be 2,079.5631 newtons, or you're gonna convert it to kilonewtons divided by 1,000. That's 2.08 kilo. Okay. Easy peasy. Hi. About here, so we have here the basic barometer reading naman. Basic barometer can be used to measure the height of the building, and most barometers are in mercury naman kasi it's much more accurate and much more practical for its use rather than water. Okay, if the barometric reading, if the basic barometer can be used to measure the height of the building, and if the barometric readings at the top and at the bottom of the building are 730 and 755 millimeter mercury respectively, determine the height of the building and assume an average air density of 1.18 kilogram per meter. What it didn't provide here is the density of mercury. So the book was assuming that you already know your density of mercury, but I'm gonna give it to you. So the density of mercury is 13,600, and you would notice all throughout the problem sometimes naglalaro yung the density of mercury plays out sometimes 13,500 kilogram per meter cube or 13,550 meter cube, but for this case it's 13,600 kilogram per cubic meter. Okay. So how do we go about in solving this? So we're given yung 730 and 755 millimeter mercury. And you know very well that we can actually get yung pressure dito. Kasi since given yung height ng mercury dito, we can actually get yung pressure at those levels. So it's by simply multiplying lang naman yung density of mercury times the acceleration due to gravity. We assume that at 9.8. And yung height, which is at points, convert that into meters at 0.73 meters, then 0.755. Sige, let's go about it. So here's we're supposed to find yung how tall the building is. We're only given yung height barometric reading at 730 millimeter mercury and 755 millimeter mercury. We're also assuming yung density ng mercury 13,600 kilogram per meter cube, and the given yung G, so we just assume it at 9.8066 meters per second squared. I'm gonna say this once, I'm gonna say it now. If there is not given here, and you know na kailangan mong gamitin here, I need you to state that in your given, or I can say that okay, here's my assumptions dito, sir. My G here, since you did not provide yung acceleration to gravity, is 9.8066. I know there's a water in the given, but you did not provide for the density, but you should already know that water is 1,000 kilogram. Okay? Since now we're given the values na yan, we, like I mentioned earlier, let's just determine muna yung pressure on the top and the bottom. And just like I said earlier, pressure can be equal to rho times G times H. In this case, this is the density of mercury, and then acceleration due to gravity, and then yung barometric reading at the top. So that's 13,600 times 9.8066, and then times 0.730 meters. Cancel, and you will be having newtons per meter squared. This is 97,359.9248 newton per meter squared. We do the same thing for the bottom, and we will get 100,694.6 newton per meter squared. And we get the difference. So in difference nilang dalawa, that must be the pressure of all throughout here in this column of air dito. That's 3,334.244 newtons per meter squared. Why do we get the difference? Yeah, because we're getting this one. So we're getting yung that must be the pressure being exerted in that column of air. What do I mean by that? Kasi ito yung pressure niya dito. Where's my pen tablet is not present. Wait lang. Screen. Matter. So here we go. So there must be this column of air dito as that pressure. Malanda dito, we already know yung density ng air. We already know yung delta P in between here. We're gonna be getting you. So just do that. Solve H. So the difference, there will be density ng air times acceleration due to gravity times h. Rearranging yung equation na yan, h equals to the p diff divided by density of air times g. And we will get, so cancel, 288.4. Okay. If you have any further questions, you can feel free to email me directly or contact me during my consultation hours. Okay, and then the last problem for the first page be the mercury manometer being shown. Did a questioning mercury manometers. This will be the next. Okay, so for mercury manometer, just like here, there's a density of 13,600 kilogram per meter cube. It's connected to an air duct to measure the pressure inside. The difference in manometer levels is 10 millimeter and the atmospheric pressure is 100 kilopascal. Judging from the figure below, determine if the pressure in the duct is above or below atmospheric pressure. And then B, determine the absolute pressure in the duct. To answer A, the easiest way to solve this, if the pressure of the duct is below the atmospheric pressure, then the level here should be a lot closer to the duct inlet here. Yes? But since the level is way lower than the duct inlet dito, pressure inlet outlet, it suggests that there is pressure here greater than the atmospheric pressure. Kasi it's pushing it eh. And remember, open rin do. So it must be pushing it greater than the atmospheric pressure. If it's equal, it's gonna spill over. I mean, it's probably almost equal to this level. So just so mag-cancel out yung pressure na yun. So you get, so I hope you understand yung logic na yun, okay? There we go. So we're given here yung density, yung H at 10 millimeter, and atmospheric pressure at 100 kilopascal. And the fact that the pressure here is actually pushing yung fluid here, whereas yung other end nito is assumed to be open, that must mean that the pressure inside here is greater than almost 100 kilopascal. And the next pressure here is, what is the absolute pressure in that duct? Yep, there we go. So the pressure at the duct is greater than the atmospheric pressure since the fluid column at the duct side here is at lower level. Now, if it's equal here, it's probably almost equal to the atmospheric pressure. Okay. So if it's a little bit higher dito, okay, almost equal to atmospheric pressure, probably less than rin. If it's less than, it should spill, the fluid should spill over dito. To be honest with you, since the atmospheric pressure should be pushing the fluid all the way here. So to get yung B, so if you recall, P absolute is atmospheric pressure times yung gauge pressure. We're given already the atmospheric pressure, so all we need to do now is identify the gauge pressure. And gauge pressure can also be expressed in terms of density times G times H. We're given this, since we have yung density ng mercury, we also have yung height difference nila. And we assume the acceleration due to gravity dito provided at 9.8066 per second. There we go. So we just cancel the units. Then multiply that by divided by 1,000 times. So 1 kilonewton, so that same units, kilonewton per meter squared. We have 101.33 kilopascal. In this case, absolute. So you can write it as kPa abs or just P abs equals to 101.33 kPa. That's perfectly understood by me. Sir, does it warrant a drawing? Not necessarily, to be honest with you, because the drawing is already here. What occasions where I need you to draw are those. For occasions that I need you to draw is when you are dealing with buoyancy. And when you're dealing with weight, so that it's not necessarily required. Pero if I said to you, if I indicated in the problem, say that, hey, draw your free body diagram dito, Meaning that will really help you in trying to solve the problem done. And for problems that doesn't really require drawing, and if you happen to be a much more of a visual person, then that by all means draw the free body diagram. Okay? Pero if it's not needed, don't do it. It's just gonna waste some time now. All right. So for the next problem dito is we have, I think it's a manometer problem tayo. So both a gauge and a manometer are attached to a gas tank to measure its pressure. I think this is kind of similar to one of the problem or sample problems I provided to you. So not all the time you're gonna use manometry. Okay, if the reading on the pressure gauge is 65 kilopascals, determine the distance between the two fluid levels of the manometer if the fluid is a mercury, or B, a water. Oh, very interesting. So we're just being we're just being asked now what will be the height difference would be if there is a difference in density. It's basically the translation lang naman. Okay, so ang solution natin, recall that pressure is density times acceleration due to gravity times h. So in this case, we're gonna be using one mercury. And then we're gonna determine your height, and this is the formula. We just rearrange the equation na to. No need to memorize. Okay, so that's Pg over density times G. And please take note, okay, where the placement of numerator over denominator and the bar in between them that separates the numerator and denominator. Okay, probably not from your class. Okay, not from your batch, but that's I just noticed I just noticed some of the second years didn't have any numerator at all, or any bar. So just write your equations properly and then do the cancellation in units, so that you know what will be left out. So that's gonna be meters. So that's gonna be 0.49 meters. Okay. And then for water, you do the same thing. And you'll be having a 6.6282 meters, or about 6.63 meters. There you go. So if you would notice, most of the manometers natin are mercury, because only a small pressure change, and then only a small height difference in change. But you will be able to know your pressure or gauge pressure. However, with water, you would require a much more longer tube, kasi tingnan mo yung change in pressure at 65 kilopascals, it generates a height difference of 6.63 meters. So you will be needing a much more longer tube to accommodate such, height difference. Whilst in mercury, when you're using mercury, you just only need half a meter of it. Okay. All right. So 3-56, that's for you to answer. So let's try naman. By the way, bonus is if you can explain why the answer is positive or negative. Okay? So I just want to hear your thoughts now that you were able to answer that. Okay. So wait lang. Here we go. So here we go. So we have a problem here. Two water tanks are connected to each other through a mercury manometer with inclined tubes, as shown in figure 3-58. If the pressure difference between the two tanks is 20 kilopascals, calculate the A, so in dimensions siya dito, and theta. We're given yung mercury at specific gravity of mercury at 30.6, and given a pressure difference at 20 kilopascals. Okay, how do we do this? Let's not be intimidated dahil nakasnatch siya. Let's just deal with the problem as it is lang muna. Okay, like any basic manometer. So let's try going from. Yeah. So first things first is we identify muna what's being asked. So we want to know yung A in centimeters. It makes sense as centimeters because if it's naka-meters yan, sobrang pangiting. But I'll mention that na naman sa problem. Okay? And then theta. You're given the difference at 20 kilopascals. So then, of course, you have the specific gravity of mercury at 30.6. And we assume that the water and mercury here are incompressible. So what's the solution natin? we solve by manometry. Say, okay, we place, let's go by A to B. Okay, A to B. So in this case, that will be, you know this, if you're following the rules, okay, from picking up a frame of reference, in this case, starting point A. As we go down, we add. As we go up, we minus. So in this case, PA, it's just PA. Plus, we have a height difference here, so that must be density ng water times acceleration due to gravity at 9.8466 meters per second. So just assume that. Kasi di naman siya binigay. And then times yung height difference ng A, so A. And then from here, we have mercury na dito at height 2A rin. And we have a slant dito, 26.8 centimeters, but that's gonna be useful later. So that's gonna be density of mercury times acceleration due to gravity times twice ng A. And then from here, we're gonna go up na kasi this is of the same level rin naman dito eh. So dito, it's another A, but that's water. So that's minus density ng water times G times A equals the pressure at point B. We arrange the equation. If you notice, this is the same as here, so that will cancel out. And rearrange the equation so that we have yung PB minus PA. That will be, so we're gonna be left with density now, mercury times G times 2A. And we can isolate further to get 2A, A into this into this equation. That will be yung PB minus PA. Density ng mercury times 2 times G. Before substituting yung mga values natin, if you notice, as sinabi ka agad dito, the pressure difference between the two tanks is 20 kilopascal, meaning one or the other, it's positive eh. Meaning kung possible that pressure B is greater than A, pag simula ka with B to A, okay lang naman yun. It doesn't really matter. Basta ang understanding natin dito, positive yung pressure difference natin dito. Okay? Okay, there we go. So substituting values, that was 20, yung pressure difference. I just converted this to newtons so that it's easier to cancel out. So, newtons cancel to newtons para pag multiply ko to, 13.6, since we're only given yung specific gravity ng mercury dito, we just have to convert it to identify yung density niya. So, 13.6 times 1,000, so that's 13,600 times 2 times 9.806 meters per second squared. So, that's gonna be newtons, cancel, and we're gonna be left with meters. And the answer is... Okay, it's that. There we go. So it's gonna be 0.07498 meters or 7.50 centimeters. Pero how do we know yung angle? That's actually a lot simpler because from here, since you already know A here, so you can get to A. And if you can look at it, we also have a slant dito. We have yung we have also yung slant length dito, which is at 26.8 centimeters. Okay? And you see yung identities natin ng angle. So if you add a line dito, they should have similar angles then. Okay, just like your old trigo. So for theta, so you would notice here, you can actually transfer yung theta dito. Actually the same thing kasi draw a parallel line here, and any parallel line intersecting this should have the same theta as this. And then from there, it's just a matter of trigonometry. In this case, it's a sine. So we simply get the sine inverse of 2a divided by 26.8. You would get 34.035 degrees per 34 degrees. Okay. All right, for this one, okay, this is a little bit complicated ng phone kasi I noticed something wrong on how the author used yung YC and area niya. So let's just identify muna ano meron tayo. So for a gate with width of 2 meters to the paper, so meron tayong 2 meters. So hindi nakikita yung width kasi naka 2-dimensional and side view lang tayo. Okay? Determine the force required to hold the gate at ABC at its location. So we're talking about this one. So it's an L-type gate dito. Again, at a hinge. So we have a specific gravity of 0.86 and specific gravity of 1.23, and we have a width of 2 meters and yung respective dimensions. Yeah. Okay, and we're here to find F. Okay, so first things first. Okay. We have two fluids dito, and the way to solve this is we have two fluids with different specific gravity, meaning two different densities. One way to solve about this so that you know yung total hydrostatic force being involved is that we convert one fluid to another so that we're dealing with only one density, since yun yung much easier way of solving it. And so in this case, let's convert fluid 1 to fluid 2 so that we solve under the same fluid. Okay? Okay, so ito yung magiging drawing nun after. Okay, so we solve that by how? We get first muna yung pressure exerted at SG 0.86. How do we do that? So pressure is rho times G times H. To know yung density nito, we simply multiply 0.86 by 1,000 kg per meter cube of water times 9.8066 times 0.50. We get 4,216.838 Newton per meter squared. And then from here, since this is a pressure, the next part dito is how much of the same pressure can this fluid provide at this okay? So at this pressure, okay, how much height of water can this fluid of 1.23 specific gravity can provide? Okay? So we just gotta equate lang here, and then there we go. So we gotta equate here, pressure here, and then to get the height at the specific gravity of 1.23. So it's gonna be 4,260.838 Newton per meter squared divided by density ng fluid na to, which is 1.23 times 1,000 times 9.8066. And the height is about 0.35 meters or 0.35 centimeters. So this is the drawing. Here's how it would look like if they have both the same fluid. This is the original. So just to show you na may gap dyan. So yan yun. So this is yung remaining let's say 50. Wait a minute. Meters pala ako dito. So this is wrong. So this is walang zero dito. There we go. That's 35 centimeters. It's the only error there. Okay. Alright, here we go. So now gate is under the same fluid at specific gravity 1.23. Now we can solve na for forces. How do we do that? So let's write down the equation natin. Remember the hydrostatic equations natin. So recall that since this is we're dealing with a projection of rectangular prism submerged, totally submerged underwater. So we know yung moment of inertia niya equals to ABQ over 12. You also know yung hydrostatic equation natin. F1 here, F2, and then F would be density times G times HC times area. So that's 1.23 times 1,000 times 9.8066 times yung HC natin, which is technically 0.25 plus yung half ng yung total length nito. So it's gonna be 0.1 times plus 0.8 divided by 2 plus 0.25 kasi yung if you recall yung HC is yung vertical distance niya from the centroid to the surface line. Here we go. Times yung area, which is 0.9 times 2 kasi yun yung width. Tayong width dito. So, hindi yan na pinapakita. Yeah. That's the most straightest line ever. Okay? So, we cancel the units. Magiging Newton yan. So, yung F1 natin will be around 10,198.26 newtons. Oh. So, for force 2 naman dito, we're talking about this. So, napapansin nyo, it's just a submerged plate horizontally. So, this one's a lot easier kasi it's just the density times acceleration due to gravity times hc times area, where yung hc was just simply 0.8 plus 35 centimeters. Okay, so 0.8 meters plus 0.35 meters. Okay? So times yung area mo, which is this is 40 centimeters times width, which is 0.4 times 0.8. You would get 11,097.1486 newtons. And then for the line of action, so at its action, technically hindi naman siya pinapahanap, but this is something that you will be needing later. And YP is equals to YC, since we're not gonna be considering atmospheric pressure because both sides are open to atmospheric pressure, so they would cancel out technically on the equation. So YC plus the moment of inertia divided by the product ng YC and area. So if you substitute them, ito yung magiging itsura niya. There we go. So 0.8 plus 0.1 divided by 2 plus 0.25 plus 2 times 0.9 cube over 12 divided by 0.8. Ito yung YC, ito yung area. So, hindi nagkakamal, ito yung YP ng F1. So, that's gonna be 79.64 centimeter, which makes sense because the greatest force should be exerted somewhere here, most close to 80 centimeters. Okay? So, how do we solve now for F? In this case, gagamit tayo ng konting moment. Okay, to solve F1, we take moment at the hinge in A. So remember, counterclockwise natin positive, clockwise natin will be negative. So then you would yield the summation of moment at A, and you would yield this following equation. So F1 times YP, and then F2 and you will yield 35.81 kilonewtons. You know what? Let me take into consideration. I think I know where the error is. So 0.7 next. What's every 0.5. I am 16,000. 2687. 11 197. 1.6. 0.4. Right? Point. Damn. I know where I got wrong. But the answer is not 17. It's 16. 16.81 newtons. 81 kilonewtons. The mistake I did there is because I forgot to minus 0.5. No, wait a minute. I think I made another mistake. So this is me finding, or it is all inside. So no. So that should be 0.7964. That's the length of YP to the surface. That should be minus 0.4. Now you multiply that by 15,198.2687. Add that up with the product of 11,197.1486 and 0.4 divided by 2 divided by 0.4. Wait, still different though. So that will be around, this should be around 20,000, 20.6 kilonewtons. Much more confident with, yeah, a lot more confident with that answer rather than 17 point. All right, so correction here, I'm just gonna release na lang yan. So YP is your distance all the way kasi dito eh. YP. It's we're gonna moment at the hinge. So we're gonna subtract the 40 dapat 40 centimeters or 0.40 meters. Okay, so that's the only mistake here. So that should be 0.396 meters. There we go. Yeah, that's a lot better. Okay, next. Oh, there's no animation deep. All right, I forgot to put animation here anyway. This one is the term. We have a problem here. So we're here to determine the resultant force acting on the 0.7 meter high and 0.7 meter wide triangular gate shown in figure below. So, and its line of action. So we're here to find your FR, and your YP. Given condition that this is, so we understand that, okay, looking at the problem, this looks like a slanted submerged triangular plate. So we want to know your hydrostatic force being experienced. We also know that for the moment of inertia ng triangular is AB cubed over 36. And then from the figure, we also know that's a triangle, so that's gonna be the base times height divided by 2. So that's 0.7 divided by 2. We also know that A is 0.7 here, and then B is 0.7, and we know that the S here is 0.3. Basically, yung that's the distance between the plate and the free surface lines. In this case, is 0.3. Okay? And then we recall that the resultant force is rho times G times HG times A, and then the atmospheric here is acting on both sides, so canceling each other out. We assume that G is 9.8066, then meters per second squared, and then density of water 1,000 kilogram per meter cube. Immediately we can actually get in beta dito, which is basically sine inverse of 0.9 and 1, that's 0.3 plus 0.7. In yung we're gonna draw here. That's gotta be your triangle. Okay? And that's gotta be 64.15.1581 degrees. Since slanted siya, yung HC mo is not it's not straightforward as HC is equals to YC. No. Because your HC here, remember, is the distance between the centroid to the surface line. So in this case, that's gonna be YC sine beta. And if you recall, YC here, and this is a triangle, okay, 2/3 of B dito, and then B. Leadership, pag rectangular prism is simply B over 2. Pero hindi. So we're gonna get lang yung 2/3 B over 2/3 B nito. So that would mean YC is 2 over 3B plus S. Substituting everything, we'll put it in the equation dito. So that's 1,000 times 9.8066 meters per second squared. We have here yung 2/3 ng B, which is 0.7 plus 0.3, which is S dito. That will be your HC. Sine of 64.1581 degrees. That's gonna be meters. And multiplied by area, 0.7 times 0.7 divided by 2. Cancel, matitira yung newtons. So we will have 1,657.8062 newtons, or 1,658. And then to solve for the center of pressure, YP, so it's just simply the formula of YP is equals to YC plus moment of inertia divided by the product of YC and area. Okay, so 2/3 times 0.7 plus 0.3. So yeah, naka-meters yan, and you would get 0.8001 meters. Okay. So I guess yung hardest part lang naman dito is just knowing what moment area to use, and of course yung area ng shape na yan. Okay? Here's another problem. This one is pretty straightforward. Dapat rin. So we have a 6 meter high, 5 meter wide rectangular plate block. The end of a 5 meter freshwater channel as shown in the figure below. The plate is hinged about an horizontal axis on its upper edge through a point A. It is strained from opening by a fixed ridge at point B. Determine the force exerted on the plate by the ridge. Okay, so determine the force exerted. So we're being asked the ridge. This is the ridge here at point B. So we need to find yung force here. So essentially, we're gonna get yung resultant force. We're gonna get yung center of pressure niya so that we know exactly where it's being applied. And then finally, mag-moment tayo to get yung force sa ridge. So just to imagine it on a different day. So here's a 3D, here's a different view. So most likely ganyan siya. And then ito yung particular dimensions niya. So that's 5 meter wide, 6 meter high total. And then 5 meters dito, then 1 meter dyan. So we're gonna find yung ridge. And given yung mga plate dimensions natin, we know yung A natin as 5 meters. And B is 6 meters. Well, not exactly. Ang B natin dito is 5 meters. So let me just correct that. Nope. Should be 5 meters. Here we go. Okay. Atmospheric pressure is again negligible since it's acting on both sides naman. And the formula for the resultant force is yung density times GHC A. So we know that yung HC natin dito, since a vertical plate though, is going to be equal to YC, which is technically 5/2 because only 5 meters is subject to hydrostatic force. Area natin is 5 times 5, which is 25 meters squared. Diyan kami nagkaiba ng buo. And substituting equation natin, we would get 612.91 25. YP is simply matter of substituting na naman. We know that the moment of inertia ng rectangular prism will be AB cubed over 12. Substituting them, we will have this. And YP is simply equal to what? So forget the cancellation dito. Is 3.3333 meters. So to solve for the ridge, we simply take a moment at point A. So mapapansin mo dito, yung perpendicular distance ng resultant force ko is YP plus yung 1 meter dot. And then minus force ng ridge, 6 meters. Isolating equation and dividing that by 6, you would get the force ng ridge at 44265 66 kilonewtons. And then finally, we have this last problem. The flow of water from a reservoir is controlled by a 5 feet wide and L-shaped gate hinge at point A, as shown in the figure below. If it is desired that the gate open when the water height is 12 feet, determine the mass required determine the mass of the required weight W doon. Okay. So, it's kind of obvious that we have to know muna yung resultant force dito. Because in order to find yung mass ng weight at point at W, we know yung resultant force, and we gotta take a moment at A dito. And we also need to know yung center of pressure so that we know exactly where the resultant force is. So that we know properly yung perpendicular distance from the hinge at point A. Okay, so I'll show dito yung pound force to pound mass conversion. We're gonna be needing that sa English to. So let's have a different take lang nito. It's gonna be like this. So sabi is 5 feet wide. So 5 feet wide. And then 8 feet yung distance ng hinge to weight. And then total height niya is 15 feet. And yung total height from the deepest part nito to the free surface line of water is 12 feet. Leaving you 3 feet between the water and the hinge. So we assume yung G natin dito as 32.174 feet per second squared and density water from 1,000 kilogram per meter cube. Now we're going to use 62.4 pound mass per feet cube. Remember, density to. So that's going to be mass over volume. So 62.4 pound mass per feet cube. And we're here to find the mass at point B. So that's going to be there. So, ang solution natin, we will need to solve for resultant force muna. Yeah. For HC here is equals to YC, so that's gonna be 12 over 2. It's a rectangular prism to, so that's B over 2, maalala nyo. And it was 6 feet. And substituting yung values na yun, we have 62.4 times acceleration due to gravity at 32.174 times HC at 6 or 12 over 2 times area, which is 12 times yung width niya times 5. Yeah. And then we need yung conversion lang dito. May K lang sa dulo para mawala yung feet per second squared and yung pound mass. Okay. You will get 22,464 force. And also for YP is equals to YC plus moment of inertia divided by YC times A. For moment of inertia is AB cubed over 12, where A is 5 feet dito and B is 12 feet. Okay? Simply substituting the formula na yan, and we will get 8 feet. And then from here, we now take yung moment at point A to get yung W. So I just draw a little bit of MPD here. Don't forget yung X and Y axis nyo. So in this case, this is gonna be YP plus essentially yung 5 na yun is 15. The difference between sa ng bank calculator, 15 minus A. Yeah, that's 3 meters pa wala. Pangit ang sulat to dito. It's gonna be 3 meters. So yun yung pagitan ng YP lang. YP is yung distance mo from the center of pressure to the surface line. And the difference between the surface line and the hinge A is 3 feet. So YP plus 3. It's gonna be 3. Hindi nag-render properly. Okay. So that's gonna be, so pag ito, so counterclockwise, ano? So FR times perpendicular distance of YP plus 3, that's it. That's pound force feet. And then minus, since clockwise to, o ganon, minus W times 8. So nilipat ko lang sa kabila to. W then is equals to 32,464 times 8 plus 3. That's gonna be 11 divided by 8 is equals to 30,888 pound force, around 30,000. In this case, this is still weight. And the tricky part ng problem na to, if I ask you about this, I need you to show me this conversion since we're being asked about the mass. So we show me this equation. Weight is equals to mass times G over K, where mass is equals to weight, W times K divided by G. And then ang conversion lang naman ito, para mawala lang naman yung pound force, magiging 30,888 pounds. Technically, parehas lang naman sila. Pero it's nice that you know how to write and convert them properly, just like writing English, proper English sentence. That's actually the last part of the problem. And if you have any more further questions, feel free to, PM me on my consultation time or just approach me in the office.